Thank you, everyone. And it's super exciting to see so many people interested in WebXR today. We are daring to give you a live demo, so please just go ahead and scan this QR code. You will be taken to a Graffiti app, and this Graffiti experience should run in AR, but it also runs on the Oculus Quest in VR. It runs on the HoloLens. It runs with AR pass-through, even on the Oculus Quest Pro. Like, hands up, who has an Oculus Quest Pro app right now? There's like one person, right? Because, I mean, who gets a dev kit for those, right? But if you are on WebXR, then it's just supported out of the box because the Oculus browser team is doing an amazing job, like, keeping up with the standard and everything. So I hope it's working for most of you. I'll give you like another 30 seconds to a minute to like play around with it, and then hope to maybe get back your attention. Maybe you're just lost for the rest of the talk, I don't know. All right, and with that, I hope at least everyone scanned it. So you heard, I'm Jonathan Hale. I'm the CEO and CTO of Wonderland Engine, and I'm here today with Bodine Beentjes, and she's the VR AR Dutch chapter president and a solutions engineer at Salesforce to bring you today some insight into who is using WebXR today in the industry. So here's a quick outline of what I'm going to be talking about, and that is just giving a rough introduction into what is WebXR. And I have the feeling that most of you already know, but I'm just going to give it a rough spin anyway. And then Bodine's going to take it from there with some motivation from the industry, who and why is using WebXR right now. And finally, if you're actually interested in building WebXR, I'm going to give you just a quick introduction how you can dip your toes into WebXR development. OK, so this is WebXR. Effectively, WebXR just refers to AR and VR based on web technology running in the browser. That means you can have a link, and anyone can just open that link and run that link on any AR device or any VR device that has a browser on it. It's just like websites, but for VR. If, for example, in this screenshot, which is taken from the Oculus Quest, you can click on the button in the middle, and then you dive into the experience and have it around you, just like any other XR app out there. All right, but why would you do this, right? Effectively, there are some very, very key advantages, very nice advantages over building for native. It's an open platform. That means you publish the content yourself without the need of going to a third-party app store. You get around the fees, but you can also keep holding your IP yourself. The result is a link that is accessible like any website, and you can share it via QR codes, as you've seen before, or via social media, for example. And finally, the user receiving that link can just jump into the experience and just load it without downloading or installing anything, taking all of the friction out of the acquisition of the user. The probably most awesome piece of this, though, is that it's cross-platform. It goes from VR to AR to 3D, one single app that runs on desktop, mobile, and all XR devices. So you can fall back to the less fun devices if people don't have them. These are some examples of devices that currently have a browser and support WebXR. And you'll probably have a more harder time finding a device that actually doesn't have a browser, doesn't have a VR, WebXR-capable experience on it. OK, so this sounds like OpenXR. Like, it seems to be just an abstraction. So, and it's true, OpenXR does abstract input and does abstract display. So does WebXR. But the key difference is that any OpenXR app needs to be installed. So you get that advantage from having a website. And the other key advantage or key difference is that OpenXR is platform dependent. So if you want to have a HoloLens experience on Windows or an Apple experience on a device that we don't have yet, you will have to build two separate apps. And that means more work publishing, more work updating. You'll have to go to various different app stores. And the web just makes that very unique and one place. So how does it work? It adds another layer on top of the abstractions that you already know. For example, communicating with the GPU, we usually do on native with OpenGL, Vulkan, Metal. We communicate with head poses or display anything to the headset with OpenXR, and we have various file I/O abstractions and USB and whatever. The browsers, like Meta Browser or Volvilk or Chrome, will then communicate with those and expose another layer of abstraction, and that is the browser APIs. We have WebGL or WebGPU for communicating for graphics. We have the WebXR device API, which is taking the role of WebXR, basically, of OpenXR, basically. And we have JavaScript and WebAssembly, which abstract running CPU code on the web and the browser. That is always installed on the user's device. So you always have that there. What is then being streamed dynamically as a website is the web page that includes the framework, which is similar to the engine runtime that you might know, and the WebXR app, of course, itself, with all of the 3D content and all of the code. And with that, Bodine will take it from here.
Thank you very much, Jonathan, for explaining all of the technicalities behind WebXR. So today, I'm going to be talking a little bit more about the industry impact of WebXR. So if we're going to take a couple steps back and we look at the type of industries that'll be who will most use WebXR, we're looking at industries that have no strict permissions, industries that are mostly consumer-facing, who have little or no control over their audience, and their audience should be easily onboarded. So that brings me to my first example, which is the education industry. So in the education industry, it's an industry that's historically underfunded. It's quite traditional in its methods. And the access to hardware is quite, usually the access to the basic mediums, as I just mentioned. So being able to offer a WebXR app that's device agnostic will make the, just stand up here. Having a WebXR app that's device agnostic will really develop the education industry. So for this, I want to take an example of Molecular Web. So Molecular Web is a company that has an web AR application where students can visualize molecular structures. So just imagine the impact that something like that could have on a traditional classroom. Next, I want to talk about retail and advertising. Now, these are industries that are historically very fast-paced, and the ability to quickly be able to develop, iterate, and test your apps is very important, and this is something that can really be helped with WebXR. And then I want to talk about entertainment. If you're creating apps for entertainment, the idea is it should be easy, it should be enjoyable, it's something that you want to share with each other. You shouldn't be spending time on downloading apps, you shouldn't spend time with focusing on which kind of hardware you have to use, it should be something for fun. And here we have examples such as Construct Arcade, we have Meta's Flowerbed project, or even the Spray Space, which is the app you guys were checking out earlier at the beginning of the presentation. Which brings me also to social connection. So we're using WebXR for social connection. I want to take the example of Secret Sky 2021. This was a music festival streamed for 10 hours. It had 16 artists and 160,000 attendees were there. They were joining from all over the world, regardless of the device that they were connecting on. So now I've spoken a little bit about the different industries that are going to be impacted by WebXR, but I also want to cover some trends as we go forward. So we're seeing the improvement of standards with W3C, the Kronos group, Metaverse standards. We're also seeing browser development. We're seeing Quest. We're seeing Volvic is also being developed. And last but not least, the web is historically open source, which really supports a culture of sharing. So finally, to look at the future outlook, there are benefits, but it's also important to recognize the challenges. So the benefits of WebXR, it's ease of distribution, as I demonstrated with the various industries that I just listed. There's also less costs, as you're able to go around the app stores. And until we get to the point where head-mounted displays are common use, or if we've agreed on a single one, having access through mobile to XR experiences is just a way to get the conversation started, to get people onboarded to these types of experiences. Then there's also employee alignment, and if we go to the challenges, what we all recognize is that there is talent scarcity, and the user interface is there could still be improvements with the user interface. And now I'm going to hand it back to Jonathan to discuss the various frameworks and the tools.
Thank you very much, Bodine.
Yep.
I think that gave you all quite some good motivation why you should be working in WebXR, why you should be deploying to WebXR. Let's see how we actually do it. Effectively, you can use one of many frameworks out there, and I'm going to go into detail in just a minute. These frameworks all produce a set of web files. That might be GLB files, that might be CSS, HTML, JavaScript files, and you just upload those to any web host that you already know. Anything that supports hosting static websites will work for you with WebXR. There's basically 3 categories of frameworks out there. One is code-only frameworks, where you literally write everything in JavaScript. You have cloud-based engines, which run in your browser and usually come with cloud storage, and you just drag and drop your 3D files into the browser, and it will manage all your assets for you. And finally, there's development platforms that you download and install and produce these files. You export some web files and upload those effectively to the web server. Of course, this talk is sponsored by Wonderland, so I'm going to go into specific detail here. Wonderland Engine is a development platform for VR, AR, and 3D on the web. It's really designed from the ground up with web in mind. We have a very high focus on performance and rapid development workflow, and of course, we support all the devices. Our focus on optimization means that we built everything in C++ from the ground up and compile that to WebAssembly to just get that last little bit of performance out. And we optimize all our shaders for WebGL2 and do optimizations that only make sense in the browser, but not on native. Our focus on workflow means we bring the web development mindset of making a change and immediately seeing the change reload in the browser to XR development. We package in less than 1 second, and our editor automatically just reloads the browser for you, even when you connect with a device. It's made for the web. That means you, of course, don't have to write in C++. You can use our JavaScript API and integrate with any browser API or any JavaScript library and harness the power of the existing web ecosystem. All right, so summarizing what we learned today. The biggest benefits of VR is that it's an open ecosystem. It is shareable, easily accessible, and the most amazing thing is that it's cross-platform. We saw some motivation from the industry. We saw that we have education, retail, ads, social, and games already building WebXR experiences and benefiting from doing so. And finally, we had a look at frameworks and tools, and we saw it's easy, fast, and easy to deploy with WebXR. And I hope you all give it a shot. Thank you very much for your attention. Oh yeah, and come by our booth. We are 214, pretty close to the Pico booth. You'll find it. All right. I think we have quite a bit of time for Q&A left, so I'm looking forward to all the questions. Is there any particular way we're doing this?
What is the state of accessibility with WebXR today? And they're basically opaque to any web accessibility tools for visually impaired, or what do you see of the state of the technology is with WebXR?
That is very true. At the moment, the technology is really early, and every early platform has trouble with accessibility. I think that's probably a general XR problem. There is some experiments that, for example, in A-frame, try to read out the parts or 3D objects that you're looking at. There's some interesting work being done there, but at the moment, we're pretty early, and I guess through the browser, you actually get automatically, for example, color blindness modes, but for some other accessibility things, you will get maybe the nature of the early technology at the moment.
What are the limitations compared to native applications, for example, on the Compass image of WebXR or Slam,
So the question is, what are the limitations, especially using Slam? And the other was Compass. Compass usage as in orientation of the phone. So orientation of the phone is accessible. I believe iOS will ask you for permission if your website wants to access that. There is SLAM tracking, either through WebXR directly or through third-party tracking libraries that you can basically use as a fallback if the device or the browser doesn't support it yet. But effectively, SLAM is supported in most devices. The app you saw should have had SLAM. If it doesn't, there might be a small bug or something, but the idea was that it does have. Otherwise, feel free to come by our booth and we can maybe show you some experiences.
What do you think is the biggest thing holding WebXR back from mass adoption?
I build a development tool. I mean, the obvious answer to me is that we need better development tools because what current native engines do for the developer is a crazy amount of a feature set. It's huge. And we're working on providing the same feature set to the user, to the developer, that developers are used to on native development. But I believe that is what makes it really fast and convenient to build also for native. But with all the advantages of the web, I believe you want to be there eventually, so we need those development tools to be able to quickly build out the web and amazing experiences there.
You do want to package everything in an app eventually rather than sending a link. Is there some sort of support for this?
Yes, so if you want to package your app, for example, to upload it to the App Store, you can either resort to PWAs. PWAs are like modern web features that allow you, for example, to add your app to the home screen. That is particularly well supported on Android, but also on desktop Chrome, for example. I know that Oculus browser, for example, also has support for PWAs, and Volvic is working on supporting them. So you can basically, without even packaging it, you can just make your app work offline and just have it conveniently installed through your website. You can also package the app with a framework like Electron, for example, which is known to be able to package web apps just as a native app, basically. A lot of applications that you use today, like Slack or Discord or all of these apps, will already be these kind of Electron apps, and for WebXR, it's not much different. Yes?
I've been using Mozilla Hubs for quite a while now.
Yes?
What kind of features or what are the priority features you're developing in your platform that is not on Mozilla Hubs or not accessible on Mozilla Hubs?
Okay, so the question is, you're using Mozilla Hubs quite a lot, and what are we building that is not on Mozilla Hubs today? Yeah. So we have a very, very strong focus on performance. We want to be able to render many objects and really like high quality, right? Just so it's actually comparable to native. We have texture streaming, for example, which allows you to have super high-res textures that just stream into the GPU when you get close to them, when you actually need that kind of area of the texture that you see in your view. And if you move back, it uses a lower resolution of the texture instead. That, for example, I don't think Mozilla Hubs has today and probably won't have for a foreseeable future. But maybe eventually they'll switch to Wonderland with some.
Is there like another, this is very graphic oriented. Is there any specific features not rendering, but I don't know, is that purely rendering engine or that's building?
It is primarily a rendering engine, exactly. So the question is whether Wonderland engine is primarily a rendering engine or if it has further features. Wonderland engine is primarily a rendering engine, yes. It takes care of everything that is performance critical. We also integrate PhysX as a physics library, so you can simulate large simulations with many rigid bodies in a very performant way, all compiled to WebAssembly. So that is our focus. And you can build anything on top of that that you may wish to do in the web.
Yes, so what are your thoughts on the impact of the rumors of Apple going into WebXR, and how would you take advantage of that on the Wonderland engine?
So we have support for Safari, for example. Since WebGL 2 was released on Safari, I believe last September, We have been working to support it, and we also have great performance on Safari there. Once they support WebXR, that will be amazing, because that means we have a device where we have super high performance tracking, for example, whether it's their AR headset that is rumored to maybe appear at some point, or whether it's the iPhone and just like through AR kit, right? Then that's amazing, because the current JavaScript libraries that do the tracking are often just like taking a little bit more overhead than the like fully implemented browser solution with ARKit would, right? And so having them support WebXR is, of course, incredible for everyone. Any last question? Here we go.
I've been developing stuff for multiplayer apps.
Yeah?
I find Unreal Engine ridiculously complicated, and Unity, like I just want a solution that gives me VR out of the box.
Yeah.
Do you support multiplayer? Do you make life easy?
Yeah, so the question is, multiplayer has been inherently hard with Unreal Engine and very complex to do. Is there a more easy solution? And the fun solution is the web makes it easy for you, right? That's not necessarily us that do it, but because we integrate with the web, it is super easy. So for example, web has WebRTC, and that allows a super easy way to create rooms and do a peer-to-peer kind of multiplayer network.
Does the syncing work?
Yes, the syncing can work.
So the web sorts it out. Brilliant. Unbelievable.
I mean, try it out. We have a nice community project called WLE Networking, which allows you to do multiplayer and voice chat and these kinds of things. And you'll be able to sync objects with that with a little bit more work, but exactly. Those things are, there are many web libraries out there that do these kinds of things, so you'll find a solution.
How is, like, from what I understand, it all runs natively on the device that you're actually accessing it with. So this is like why also you can have it offline as a PWA, is that right?
So the browser runs natively, yes, but what a PWA does to run offline is it caches the entire website basically to have it present even with the internet connection being unavailable.
So my question being is, like, it basically has to be pretty big, and talking especially about textures and high resolution.
Yeah.
So you said like an optimizer, which sounds very interesting to me. I would probably need to ask her right now. I would love to see that, like, in real life, how that actually looks like, because in my head, in my world that I'm living in, it's
Yeah.
pretty heavy. That sounds to me something like, visually, how does it really affect actually the visuals and the textures and the lighting and the reflections?
Yeah.
At the end of the day, when it is actually so compact that you can even actually store it in cache on your device.
Yeah, I mean, I'm happy to talk to you later. We do GPU compression of the textures, what most native engines do too, though. But yeah, we're just a super lightweight runtime in general. I think that was our last question for today. Thank you very much.
Unfortunately, run out of time for questions, but you can find Jonathan and Bodine at the event and ask away if you have any more. So let's give another thanks for them. Thanks, guys.